Hi Cullen, this is a video to help you with the problems that you sent me today. There's sections 2.3.1, which involves adding and subtracting fractions, and then 2.4.1, which is multiplying and dividing fractions. One of the things that everyone finds super confusing about fractions is that there are different rules for the different operations, adding, subtracting, multiplying, and dividing. That's what's confusing, is that there are different rules and it's very hard to remember which you do when. So whenever we're adding or subtracting, same rule applies. The denominators must match. Before we can add or subtract, we have to make sure the denominators are the same. Then once we get the denominators to match, the process is quite easy. So let's tackle one. Let's start with the first problem. And first of all, I want to show you, I copied the problems down on this piece of paper. This is the way they're written in your instructions with the fraction line on a diagonal. That is most unhelpful. That's the way these look on most measuring devices, which I assume is, your reference point as a tradesman is, measuring tapes. Their fractions are written like this, but for purposes of calculation, this is extremely unhelpful because it kind of blurs the numerator, the top, and the denominator, the bottom. It kind of blurs them together into one blob. When I add fractions, I have a very specific format for the way I lay out the problem, and I want you to copy it because the format of the problem will help drive your understanding of the problem, okay? So the way we set problems up matters, and I've been teaching math for 20 years. I've been teaching algebra for 20 years, and trust me, this is the way to understand the problem. So instead of writing it 1/8 plus 4/16, I'm going to take the same problem and I'm going to write it like this. 1/8 plus 4/16. See how my denominator lines, or my fraction lines are straight, and I've got a clear top and a clear bottom? Numerator, denominator. Those are the fancy words. We can say top and bottom. You will understand the rest of the thing I'm explaining much better if I don't use the confusing words. Okay, so this is our addition problem. We always stack them because we need this space to do our adjusting. So it's important that you set it up this way. I know, I'm repeating myself because I really mean it. Studies say we have to hear something 7 times before we actually remember it. I'm not gonna say it 7 times in a row, but I will say it 2 and maybe even 3 times in a row because that's how you know it's important. All right, so what we do is we look at our denominators. They have to match. Do they match now? No. 8 and 16 do not match. But what we do now is we start to play around with multiplication facts in our heads. And we're looking for a number that both of these numbers will fit into in terms of multiplication, that we can multiply this number or this number by so that they'll be equal. And what we quickly see and notice is that 8 times 2 equals 16. Aha, so that tells us that if we multiply 8 times 2, we will get 16, and then they'll match, won't they? We can do that. We can multiply the bottom of this fraction by 2 to get the 16 that we want, but only if we multiply the top by 2. And the rule here, I'm going to make this into a box, and then I'm going to make it look kind of like a 1. See how it looks kind of like this style of a 1, right? Kind of. We can multiply a fraction by another number as long as that number is equal to 1, because we know that any number times 1 is just that number back. So when we multiply by a fraction that's equal to 1, we are changing the shape of the fraction without changing the value of the fraction. So 1 times 2 is 2. We have to do that in order to keep this in balance. And you can agree that 1/8 and 2/16 are the same number. Okay, cool. So we haven't ruined anything. Now in this case, we have a fairly easy one because we only had to adjust one of the fractions. And the second one, because we made this one fit easily into this denominator. And what we say here, the least common multiple equals 16. That means 16 is the first number that both of these denominators will easily fit into. And so we use that as our target over here, right? This is the LCM. Least common multiple, okay? Least meaning the smallest. Common meaning they both fit into it. Multiple meaning that both of these guys can be multiplied to fit into that number. 16, we don't have to adjust. It's already there. Okay, so now we're ready to add, and we get 6 over 16. Okay, that's a really great answer. And notice how I did that. I added the tops, but once you get the bottoms to match, you don't have to do anything with them. You just leave them in that same value, right? So I added the tops, and I just carried the bottom through. 2 plus 4 is 6, okay? Now, what we notice is this can be reduced, right? Because we can see really quickly that these are both even numbers. So that means we know for sure that we can divide top and bottom by 2. Again, as long as we're dividing by the same number, it's like dividing by 1, and that doesn't change the value, it only changes the shape. 6 divided by 2 is 3. 16 divided by 2 is 8. So we see that our final answer here, this one is the 1. See, it's like this, where we're changing it by 1 only. So our answer is 3/8. We always want to reduce our fractions as much as possible. And in your materials, we want to show it as a mixed number, not an improper fraction. And I'll remind you of what that means. An improper fraction means the top is greater than the bottom. And so the value of the fraction is greater than 1. And so that's when we start writing it as 1 and 1/16 or whatever we might have. But that's where we have a combination of mixed numbers. In algebra, we do not like mixed numbers. We would much rather have an improper fraction. But I notice that in your materials, your instructions tell you that they want the answer in the shape of a mixed number, which I suppose makes more sense because I'm just thinking of measuring tapes. Maybe I'm oversimplifying. But that's the way you're going to get your measurements in a construction setting, okay? So we'll work with that. All right, so the answer to the first one is 3/8. Let's do one more. And then I will turn you loose to try the other ones. I don't want to do number 2 because it has the very same denominators. Let's do number 4. All right, this one, 3/4 plus 2/8. Okay, notice I'm giving myself lots of room. And notice again, this is the way it's written in your materials. That is most unhelpful. Write it like this, stack them. This is called a vertical presentation for obvious reasons. And it gives you room to adjust your fractions to the side. So now we're looking at our denominators and we have to find the least common multiple, the lowest number that both of these numbers will go into. And once again, sometimes you have to adjust both of these denominators. But in this case, in all of your problems, I'm noticing you only need to adjust one. 4 goes into 8. 4 times 2 equals 8, right? So that tells us our least common multiple is 8. And we're going to adjust this fraction by changing not the value of it, but the shape of it by multiplying by 2/2. This is equal to 1, so that tells us for sure we're not changing the value, we're only changing the shape, and then we multiply through. And then we check our logic. 3/4, does that sound like the same thing as 6/8? Yeah, that makes sense. All right, now our denominators match, right? We have 8 and an 8. 2/8, I write it underneath the other one. Very often, we have to adjust both top and bottom. So these problems are all very kind, and I'll remind you of that in just a second. Okay, 6 plus 2 is 8. The denominator stays the same. So our answer is 8 over 8. But whenever the top and the bottom are the same, we can simplify it as 1. So that is our final answer. That's our final answer there. I always put smiley faces because I always have my students check their work and put some sort of an indicator that they've checked their work and it's correct. Okay, so the answer to number 4 is 8. So let me copy these answers onto our sheet. This is what I copied from what you gave me. 4, the answer is 1. I'm gonna finish these problems on my own later, and I will take a picture of this page and send it to you so that you have the answers to all of those problems. Okay, so just to recap, when we are adding or subtracting fractions, the denominators must match. And so that's our first task, is to find the least common multiple, right? That's what LCM stands for. Let me just write that out. Least common multiple. And again, that's defined in simple language as the first number that both of these numbers will fit into. And in all of the cases of your problems, let's just look at them because you're going to be doing these. Look at this. 8 and 16. Well, 8 times 2 is 16, so that fits perfectly. 8 and 16 again. So we'd have to adjust this one by multiplying it by 2, and then we'll have 16 over here. 4 and 4, oh, those already match, so we're good. 4 and 8, this is the one we just did. We adjusted the 4, we multiplied it by 2, because that equals 8. And then this one we have the 16 and the 8 again, so we multiply the 8 by 2. All right, so in all of these, you're just adjusting one side of the fraction and not both. All right, that takes care of the first section that you asked me about. Now we get to 2.4.1, and this is about multiplying and dividing fractions. And here's where everyone gets confused because the rules are completely different. We don't care if the denominators match. Denominators don't need to match. It's okay if they do, but it's fine if they don't. And once again, let me just show you, these are the problems as I copied them out of the page you sent me. This presentation is unhelpful for doing the calculations. Whenever we write the fraction with a diagonal, and these two are more or less next to each other, we are confusing the top and the bottom. It's hard to see that. We're blurring those together into one blob. So I'm gonna do the first problem, and I'm gonna write it horizontally. I'm gonna continue with the horizontal format. I'm not gonna go vertical like we did here. That's necessary for adding and subtracting. It's not necessary for multiplying. So I'm gonna write it like this. 4 over 16, and I'm gonna use a dot for multiplication. That's another symbol. I think I've used that before and you might have wondered about that. In algebra, we do not like to use X's to show multiplication because we're using X's for other things. So in algebra, we use a dot to show multiplication, and then later on, we do a lot of work with parentheses to show multiplication. So I tend to do this. That may confuse you. Sorry, that's why I'm explaining it. Okay, so this is number 1. Now, when we multiply by fractions, we multiply the top, straight across the top, and straight across the bottom. All right, it's as simple as that. So I could multiply these right off and I would get 20 over, oh boy, what's this one? 128, I believe. And this is, well, let's just multiply it out. I don't want to confuse you with how I do it in my head. 8 times 6 is 48. I put down the 8, I carry the 4. 8 times 1 is 8, plus 4 more is 12. Okay? Now, that's the correct answer, but we have a lot of reducing to do, don't we, in order to get that down to a number that is stated in its simplest terms, that's fully reduced. And we could do that, but let me show you another way to go about it. And I'm just going to rewrite the problem. What we do is we cancel before we multiply. And what that means is we're looking for patterns in the numbers where we can essentially divide the top and bottom by the same number. So, for example, I notice that there is a relationship between 4 and 16. Both of these numbers are divisible by 4, aren't they? So I'm going to do that. I'm going to mentally divide 4 by 4. That will give me 1. And I'm going to mentally divide 16 by 4, and that will give me 4. Does that make sense? So we're looking for patterns in any number in the top with any number in the bottom. I could have reduced this 4 against this 8. I would have crossed this out and written 1. I would have crossed this out and written 2. But I just chose to do it over here. It doesn't really matter. I left it that way because it seemed I wanted to get rid of the bigger number first. Now I'm looking to see if there's any other patterns. Does 5 go into 4? No. Does 5 go into 8? No. This is already a 1, so I know it's reduced fully. Now I can multiply through, and my fraction is going to be much smaller. 1 times 5 is 5. 4 times 8 is 32. That is a reduced answer that we can live with. And I believe, let's just see, if we divided this top and bottom by 4, I just quickly reviewed in my head what numbers go into both of these. 2 for sure, because it's even, but I quickly did the division in my head and see that 4 will work. And so when we divide 20 by 4, we get 5. And when we divide 128 by 4, we get, right? 4 times 3 is 12. I subtract, I get 8. 4 into 8 goes twice. And so there it is. It's kind of squished in here next to the side. But look, we get the same answer either way. This is the correct answer. We could have found it by multiplying and then reducing it, but it's much easier to cancel before we multiply, and then our answer is reduced. And the way I put this simply is to say I'd rather make my numbers smaller before I make them bigger. So I like to do my canceling right away. Okay, so that is the first one. And this equals 5 over 32. And let's try number 4. I can fit it here. 4, 3 over 7. Again, I changed the presentation. I do not want a diagonal fraction line and a blob. Times, now look what happens when we multiply by just a plain number, 49. I don't want to write it as anything but a fraction, so I immediately change it into a fraction by putting it over a 1. Super important, right? Whole numbers we place over a 1 so that they can be, well, this is the way I always say it, they're in the, we want to put them in the fraction club, right? Whenever we're doing an operation, adding, subtracting, multiplying, or dividing with fractions, we want everybody to be in the fraction club. So this is how I can turn 49 into a fraction, is put it over 1. Now we're ready to check and see, is there any canceling we can do before we multiply? And this is where it really helps if you know your times tables well. 49 and 7 have a relationship, don't they? 7 times 7 equals 49. So if I divide 7 by 7, I get 1. And if I divide 49 by 7, I get 7 again. Now I have 1s in both denominators, so I know there's nothing left I can cancel top or bottom. Remember, you can do anything in the top against anything in the bottom, but you can't go side to side. Okay, but this is cool because what I have is 21. 3 times 7 is 21. 1 times 1 is 1. And so my final answer can just be stated as 21. And that is number 4, so I'll write that here on the answer sheet. All right. And we don't like this presentation. This is much preferred. All right, so there are 2 examples of multiplication problems, which was this first section. There are 5 of them here. We did 2 of them. Again, I'll complete these and send you the answers. Let's talk about these division problems that are down here. Division is a lot like multiplication, but it has a twist. Let's try number 6. It is written as 3/8 divided by 3. Again, we're going to put 3 over 1, right? The problem as it's given just shows us the whole number. We're not going to leave any whole numbers in our setups. We're going to immediately put them into the fraction club like so. But here's the twist when we divide. We have to do 2 things. First, we change the division sign to a multiplication sign, and we flip the fraction that follows the division sign, okay? Those are the 2 important steps that we have to do. They're easy steps. They're way easier than that whole least common multiple thing. But we have to remember that what we do when we see a division problem is we change it into a multiplication problem. First, that's my little flip sign. I change that into a multiplication dot or an X if you prefer. I'm just a dot person. And then we flip the fraction that follows. So this becomes 1 over 3. This stays the same. There's no rule affecting that, right? So we flip and flip, okay? And that's what those little signs are indicating is the change that I did. Now we just multiply. And again, we can cancel, right? We always cancel any top to any bottom. Okay, we can go across like this, or we can stay within the same fraction. Sometimes we'll even have 3 fractions, and we can go in any patterns across and bottom. We can cancel any top to any bottom. That's what I wanted to say. Nothing to add to that. Okay, these are puffy clouds of knowledge. They help you key in on what's important. All right, so we see these 3s. We can divide both of them by 3. 1, 1, and so our final answer is 1/8. And I'll write that right here. Notice that the form of my answers does not look like these because I don't believe in these diagonal slashies. You can write it that way if you want to, but I will always stick to this because it's so much clearer what the presentation is. Okay, and then let's just do one more. Let's do number 8. Here's number 8. It's 3/4 divided by 3/8. So I'm going to write it in that format, switching those diagonal fraction lines into straight ones, writing it just the way it was, and then I remember to make my 2 changes. The first part stays the same. This changes into a multiplication dot, and this guy just flips. 8 over 3. This may seem random and arbitrary. If you continue on in algebra and in studying fractions, we will eventually prove why this method works, why these 2 seemingly very random rules make sense. For now, I ask you to just trust me that that's something that will actually be proven later and that it works. And as long as you memorize the mechanics, you don't have to worry about the theory. Okay, then we're going to look to cancel any top to any bottom. The 3's cancel. They both turn into 1s. And then what about this 8 and 4? 4 goes into 8, right? So if I divide both by 4, 4 divided by 4 is 1. 8 divided by 4 is 2, and look what we're down to. I'm just going to circle them so you can see what we have left after we do all of our canceling. And now we multiply straight across the top. 1 times 2 is 2. Straight across the bottom, 1 times 1 is 1. And then we can write that number just as a whole number. And that's the right answer. And that's number 8 equals 2. All right. Let me know if any, okay, so we've done, let me just show you. We did 2 multiplication problems, 2 division problems, and then we did 2 addition problems to start. You have the rest of this work to do. Like I said, I'll send you the answers. If you are struggling on applying what we learned to any of these other problems, then let me know. All right, thanks, bye.